This is Anastasio G. Pantaleon Jr. and again welcome to my YouTube channel. Today we will be continuing the mixture problem of an application of the first order differential equation. Now this time the volume is changing and also the concentration is changing. So let's go and learn. So I'll be giving you the mixing problem principles. In these problems, we will start with a substance that is dissolved in a liquid. Liquid will be entering and leaving a holding tank. The liquid entering the tank may or may not contain more of the substance dissolved. Now this time, the tank may contain, okay? Liquid leaving the tank will of course contain the substance dissolved in it. If y to the t gives the amount of the substance dissolved in the liquid in the tank at any time t, we want to develop the differential equation that when solved will give us an expression to the function of t. The main assumption that we'll be using here is that the concentration of the substance in the liquid is uniform all throughout the tank. The main equation that we'll be using in the model in this situation will just be the same as dy over dt is equals to rate in minus rate out. So we have the problem. A tank initially contains 1,000 liters of water with 15 kilograms dissolved of salt at it and at a constant mixing to ensure the uniform concentration. However, unlike the first problem, the earlier problem that is presented, so if you want to see the earlier problem, I have put on the link in the description below. So a brine with 0.3 kilograms per liter enters at a rate of 16 liters per minute. Okay, it has increased while the tank drains at 15 liters per minute. So there's a difference of 1 liter per minute. So what do you mean by this is that the volume of the brine in the tank is increasing. Okay, the input is much greater than the output. So the main question here is that how much salt in the tank after 10 minutes. So we have to be very clear in this. So this is the 16 liters per minute. Okay, with 0.3 kilograms of salt per liter, while the output is 15 liters per minute. Of course, the concentration depends upon the time of how many salt has been mixed in the tank. Okay, so that means that the change of volume is equals to the difference of the input minus the output. So we have 16 liters per minute minus 15 is equals to 1. And we have to make it as a multiplication of time, as a function of time, since we are to increase or to decrease it in liters per minute. So for example, if we have here 17, if we make it 17 and still this is 15, this makes a difference of 2. So that means there are additional 2 liters per minute, per unit time. This makes that 17 This makes it 15, and this becomes 2t. Okay, so you must be clear with that, or otherwise, if this is 16 while the output is 20, okay, it has reversed. So this is 16 minus 20, and we have negative 4t. So I hope you're clear with that 1t means that there is 1 or a positive increase or an increase of volume per unit time. So that is 1t. So again, we have the rate in. So the rate in is equal to, we have 16 liters per minute. Okay, multiplied by 0.3 kilograms per liter. So that makes it 4.8 kilograms per minute of input of salt in the tank. So we have the rate output. Which makes it y, okay, to the function of time over the initial volume. Again, since there is an increase or a change in the volume, we must also include that in the volume part. So that is t, okay? A function of time t. So therefore, your equation becomes dy over dt is equals to input 4.8 kilograms minus y, okay, to the function of time 1000 plus t. And if we arrange that here, dy over dt, okay, this becomes plus y over 1000 plus t, which is equals to 4.8. And to recall for that is that it's the same. Dy over dx plus p to the function of x times y is equals to q of x. And we take note that we need to determine first an integrating factor phi equal to integral of p x dx. Now, at this example, we have phi is equals to e integral of dt over 1000 plus t. Those will let you is equals to 1000 plus t, and du is equals to dt. So therefore your phi is equals to e to the integral of du over u, which is then e to the ln of u, which is just equal to u. And of course, your u is equal to 1000 plus Those you're integrating or your function of mixture is y to the function of t is just equal to the inverse of the integrating factor multiplied by integral of q to the t, okay, times your phi plus c, okay, those making it -1. However, your qt is 4.8, so it is a constant, so we have to, it is easier to be not that part of integral, which is your phi is 1000 plus t, okay, dt, okay, I forgot here dt, so we have dt plus c, okay. Now to make it simpler, because they are all the same, this phi has the value of 1000 plus t, so we let v is equals to 1000 plus t, and dv will just be equals to dt, okay. So this makes it phi, the inverse of 1, 4.8, integral of v dv, okay, plus c, right? So that makes it phi -1, 4.8 v squared over 2 plus c. So that makes it again phi inverse 1, okay, 2.4 phi squared plus c, and unmasking the v just equals to 1000 plus t, the same as u, or the integrating factor 1000 plus t. 1000 plus t to the inverse, okay, 2.4 times 1000 plus t to the 2 plus c, okay. So distributing our general equation will have, say, 2.4, okay, multiplied by 1000 plus t, okay, and plus c over 1000 plus t. So this is your general equation. Let us say this is y to the function of t is equal to, okay, this will be equal to 2.4 times 1000 plus t plus c over 1000 plus t. Y to the 0, initially you have 15 kilograms and equal to 2.4 times 1000 plus 0 plus c over 1000 plus 0. So those you're making a c of equal to negative 2,385,000. 1,000. So at 10 minutes, y to the function of 10 minutes, okay, your concentration is 2.4 times 1,000 plus 10 minus 2385000, okay, plus 1,000 plus 10. Therefore, the concentration of salt in the tank after 10 minutes, or the amount of salt in the tank after 10 minutes is, we have y to the function of 10 minutes is equals to 62.63 kilograms. So that is the final answer. So hope this video made it clear to you about the difference of the changing volume and the concentration involved. Okay, involved. Thank you, and see you in my next video.